Hi everyone, this is Kevin with Map Practical. This is Applications of GIS Lab 1. We're going to be making some Choropleth maps, as you can see here, and we're going to be doing some demographic analysis. Really trying to compare the relationship between education and income in the United States. So I give you a little bit of an introduction here, and then talk a little bit about the economic theory that kind of backs it all up. And then I send you off to the National Historic Geographic Information Systems website. So let me pull that up over here. Part one is going to be mostly getting the data. It's a little bit tricky, but it's not too bad. So here on the website, you'll have to make an account if you don't already have one. And then you'll just click on the Get the Data button here. And then we'll have to make some choices. So the census data that we're after, it's actually American Community Survey data. It can be difficult to get off the census website. So there's a number of different organizations and government offices that make the data a little bit more accessible. I think this one's a little bit easier to use than others. Anyhow, so you'd go to Geographic Levels, and then we're going to choose County. You just click on the little green button there and say Submit. And you have to follow these instructions exactly or it just won't work out. And then it'll populate. So now there's over 39,000 source tables. Obviously we're going to have to pare that down. So we'll go to the years, and under years we're going to be looking at the census years 2010. So we are getting a new census done last year and the results being worked up. So soon we'll be able to update this with the latest data. And then under topics, we're going to have to look under the population tab right here. And under general, we're going to do total population. And we have to scroll down and look at education. And this is going to be education attainment. And then we're going to have to go down to income. And we're going to go ahead and check the box there for personal income and say submit. So each time you see how it populates things and then it's looking through and eventually the tables will show up here. The reason no tables are showing up now though is because this Boolean operator has AND in there. So you would need a table that has in one attribute population, education, and income, and that doesn't exist because they're in separate attribute tables. So we have to tell this to be OR, and then you get a lot more, right? So that's just a little pointer there. And then under data sets, we're going to have to go in and figure out which one we want. And it turns out we're looking back to 2010, so we'll scroll down, and then under the 2010 American Community Survey, we're going to grab the 2006 ACS 5A. So that's it right there. So it's 2006 to 2010, American Community Service 5A, or survey, and then we'll grab that and say submit. And that pares it down even more, okay? And then down here, now we have source tables, and we're down to 20. So now we're going to choose which ones we want out of this. So the ones that we want are, and I give you guys in the instructions, which will be down in the description of the video, the actual coded name. So you got to double check to make sure. So this is the B01003 total population. That's one of the ones we want. And then we got to go down to a 002 sex by education attainment for populations 25 and over. I'm going to grab that one. And let me just look at my instructions over here. And then we also need to grab the aggregate income in the past 12 months, and that's 313, so B19 313. So that one right there. Okay? All right. And then we have to go over here to the GIS files, and we're going to choose the county GIS files. Now with most census data, it's not spatially referenced right off the bat. You get a big spreadsheet full of data, but in order to get it into GIS, you're going to have to join it with a shapefile, and in this case of all the counties in the United States. And I'll walk you through how to do that. So, but we're going to choose that county shapefile. Back to our source tables, we got 3 source tables, 1 GIS file, right? So then we're going to go ahead and click continue up here. So the data chart is what we're after over here in the corner. And take a look and make sure we have everything. Sometimes it'll give you an error saying you haven't selected the geographic level, and that was only if you didn't select by county before, so you might have to select it here, but we're good to go. It's not giving us any kind of an error, so we'll hit continue again. And then we want to tell it what kind of files we want. So we're going to get a comma delimited file, which is going to be an Excel file. We're going to include additional descriptive header row. That just helps us figure out exactly what the coded values mean. And we're going to go with this default here that says combine different breakdowns, data types into a single data file. That's so we don't get a separate Excel sheet for education, population, and income. And then we'll hit submit. Okay, so you can see I've done some orders in the past, been working this lab up for a number of years. So what'll happen is eventually, right now, it's working in the background to collect all your data, and if you were to hit the refresh button, it may change. So already the GIS file is ready to go. So then you would just click on this guy right here, GIS, and download it. All right, so this will pop up, and then I'm going to go to where I have GIS applications. And I haven't made a Lab 1 folder yet, but we're going to do that when we start the ArcPro project. So I'm just going to make a raw data folder. No spaces in GIS work, right? And I'm going to put the zip file in there and save it. Great. And we can hit refresh again and see if our tables, so the cookbook preview is ready to go for the tables, but not the Excel file. I could just download the ones that I had found yesterday. If you don't have time for this, or if the servers are really busy, it might take a long while, you will get an email from the website that tells you that your data is ready, which can happen if a lot of people are trying to hit the same data at the same time. Let's just one more time check it. No, it's still not ready. I'm going to go ahead and just download it from the search that I did yesterday because I know it's correct. All right, so go ahead and save that. Super. So we've downloaded our data, so now we're done with the internet. And let's go ahead and take a look for it. Where would it be? I'm going to go into my views here. All right, so I'm in the Windows environment. Obviously, if you're going to unzip files, you need to be in the Windows environment. There's my raw data folder. So I need to unzip these two guys. I'll right click. And if you have 7-zip, you can just go to, or pzip or whatever unzipping software you have, extract to, and this is going to create a folder that's the same exact name as the original zipped file. So there's that. And then we'll do the same thing for the shapefile. Now, what I've noticed, though, is that this shapefile is double zipped. It's not that big. I don't know why they did it like that, but so if you go now in the folder for the shapefile, you'll see it's another zip, and we have to unzip that as well. And extract to. Cool. I think probably the best move is to copy this guy or cut it, go up one level, and paste it in here. There we go, and then get rid of the other one. Just delete that. Super. I'll just double check. So I've got two things. I've got a Excel file and I've got a code book, and this is actually a text file that gives me like the metadata on all the different attributes. And then double check that this one is a shapefile. Super. Now if you want to wait to delete your zips until after you've gone through and processed all your data, that's fine, but I'm pretty comfortable with getting rid of them now. I also know I can get them again off of the website. All right, so now we got to do a bunch of data management. First things first, let's go ahead and start an ArcPro project. So I'm going to go here, I'm going to start up ArcPro. And as usual, it's going to ask me if I want to create a project folder and all that, and I'm going to do that. So here's ArcPro. I'm going to go ahead and just start a template that's a catalog, and we can make maps inside of there as well. So I'll go ahead and do that, and then the project is going to be GIS _ apps, and this is lab 1. Okay, and I'm going to tell it to put it in the folder I've already made for GIS apps. So it's under my documents, and you might have another place for it, but there's that. Great, and definitely want this box checked to create a folder. So we'll say OK. And then it's just going to create a new project for us. And so we're in a catalog pane there. We got our contents pane, all the usual suspects. So now I'm going to go back in the Windows environment real fast and go out of here. And I've got my GIS apps folder and I've got my raw data. I want to put my raw data inside my new project folder. So I'm going to cut it. I'm going to go in here, right click and paste it right in there. Excellent. So this is the project folder. They automatically made me a geodatabase. There is the ArcPro document. It made a toolbox and other things that I may or may not use. So now I've got everything I need. All right. So now we're going to, let's see, go back to ArcPro and do a little bit of project layout real quick. So we've got the raw data folder in there. Yeah, so now it'd be a good idea for us to go down to our folders And let's go ahead and refresh the connection here. So the GIS apps, refresh. Now if I take a look in that folder, boom, there we go. So there's our raw data. And let's take a look at the shapefile. So there's our county shapefile, and I'm just going to look at its properties and the spatial reference. So in this particular case, spatial reference is a USA contiguous Albers equal area conic. Great, well we're making choropleth maps, and you should always use an equal area projection, so this should work out perfectly. We're also going to condense our data down to just the contiguous United States, so this is all set for us. So we don't really need to do any projection manipulation in this data. So what we can do though is go up to our database, and here's our GIS apps database it made for us. I'm going to right click on this guy and say new and feature data set. And you want to name the feature data set. We can just call this US data if we want. That's not super important, but definitely we're going to have to set this coordinate system. So I'm going to hit the little select coordinate system button here. And this guy's going to pop up, and we could go through and dig through all the folders and set it, but I'm just going to import it from the original shapefile because that's what I want it to be in. So I'm going to go underneath here and go import coordinate system, and then look in my folders, look in my raw data, look in my shapefile, and import it from that US County shapefile. Say OK. And there it is, US contiguous Albers, and say all right. And then run this guy. It worked out fine, gave us the green light. Now, if we look inside of this guy, there's our US data. And now we can import that shapefile right into it. Just make sure I'm doing everything right. All right, great. I'm going to import. And we're only doing one thing, but I'm going to go ahead and call it feature classes. That way I don't need to rename it. And I can literally just drag this US County in there. It's going into the US data, and it's going to remain in the same projection and coordinate system that it's already in. Let it run. And there it is. It's done. Green light. Super. So now if we go up to our US data, boom, we have counties right there. And we can look at this guy in catalog view by looking at geography. And give it a second. There it is. So it's all the United States, Alaska, Hawaii, and I think it also has Puerto Rico in it. And then we could always just take a look at the table if we're interested in knowing what attributes it has. It's got a lot of attributes, including some that we don't need because we're going to be importing new data into it. But the one thing that's really important to note is this field in here called GIS join. And that's a special coded value that is matched in the attribute table that's in Excel right now that we will join to this geographic feature. All right, so back to metadata. We can make this thing smaller. And we'll eventually come in here and we'll create a new map. But for now, I'm just going to save the project. And we're all kind of set up in the first part of it. So now I'll go back to the Windows environment. So here I am in my project folder, and I'm going to take a look at my raw data, and we're done with the shapefile manipulating. So let's take a look at this Excel file. The code book right here that's a text file, if we open that guy, what you'll see is that it's the metadata. And it just tells us what the coded values for all the different attributes are. So when we open up the Excel file, this will make sense, but here are all these coded values, and this is what they actually are defining. And so for this particular thing, since we're trying to compare total people with an education of a bachelor's degree or higher to the median income, we're going to be getting rid of some things. Like, so we're not going to deal with males or females that have no schooling, nursery to 4th grade, so on and so forth. And we're going to make it a cutoff at bachelor's degree up to doctorate degree, okay, for males, and then the same thing for females, bachelor's degree to doctorate degree. All this other stuff in between, we'll be able to get rid of that, okay? So if you need to reference this, it's good to have the text file around. And then we'll open up Excel. Let's bring this guy over, and we'll start working this thing up. So there's a lot of data that we can just get rid of right off the bat. So the GIS join, super important to keep. The year, we don't need. Certainly we don't need these columns that don't have anything in them, so we'll just delete those. Alabama, the state name, let's keep that. And you'll see that there's a couple of things. So you've got like a header row with state, but then a little extra information in row 2. So eventually we want to have just one header because that's the only way that GIS will read it properly. But for now, we'll keep all these. I'm going to keep my state name. I don't need the state code, so we'll delete that. I don't need my county code. I can delete that. I'm going to go with the county name, though. We'll keep that. And then all of these ones that are empty, those can all go. So I'm just holding down the shift to select multiple, right? And let's get rid of these couple of other ones. Delete, and then let me look back to my instructions to make sure I'm doing everything right. Okay. So we will notice that this is the name of the county again. We don't need that one. And there's some of these that we don't really know exactly what they are yet. So this is estimates total, but total what? I'm not sure. That coded value can be read over in the metadata, and that'll let us know. But we do know that we want to get rid of male no schooling, right? And then we might have to go over and open up some of these. So there's the male bachelors. So everything below that we're going to get rid of, right? So I'm going to go ahead, and so this is the males no schooling all the way up to associate's degree. So we're not expecting the associate degree to affect median income too much. We're making some subjective decisions here, but so for this particular analysis, this is what we're doing. So we'll delete that. And then we got to do the same thing for females, right? So let's see here. So keeping the male master degree and all that, and let's go up. All right, so here's females no schooling. And let's take that all the way up until we find female some college. Nope, that's not going to cut it. Associate's degree. So from no schooling to associate's degree, and we're going to get rid of that. Very good. And then what is this one? Estimates aggregate income. That one we're going to keep, okay? And what's this one right next to it? Female doctorate's degree. Okay, so we're keeping that. But then all of these margins of error, we're not going to be doing error analysis for any of these, so we can get rid of almost all these. So I'll go ahead and get Q out of there and scroll all the way over to this BB and say delete. All right, so now we're getting pretty close to something we can work with. What you're going to do is change some of the names on these guys. So estimates total in row 1, and let's scroll back over here. And it's called JMA. So JM, that's JMAE. Let me make sure. JA. Oh yeah, so this is the total population. JMAE001. And it says total, but it ends up it's total pop. So we're going to change that to total pop. Cool. And we're going to be able then to delete columns JNE00E or 001 and 2 and okay, so we're going to get rid of those two. Great, so we've got a total pop, and then out here this total income one, we're going to rename that one total income. So see, that's the aggregate income in the past 12 months. So we're going to go ahead and call that total income. Super. Probably important to get an E there. There we go. All right. And let me just check my instructions. Okay. So we've gotten rid of everything we don't need. Now, next to this total income, to the left of it, so if we just right-click and say Insert, it inserts a blank one here, and we're going to call this one Total EDU. _EDU. And so what we're going to do is just calculate a sum of all of these educated people and put it right here, okay? So how we do that is then we just go over to the formulas, and then there's an auto sum, and it should grab all those, and you just want to double check and make sure it's grabbing. All right, so it doesn't, we don't want it to grab the total pop, right? So we want it to grab all the males, bachelor degree, masters, and doctorates, and professional degrees, and then the female from bachelor's all the way to doctorate degree. We'll hit enter. All right, so that's that guy there. And then if you select that and there's a little tiny square on the end of that, if you double click, it'll now calculate down through the whole entire column. And we can get rid of this error all at once, and it's just saying that it omits the adjacent cells, and that's the total pop that doesn't need to be in there, so just ignore this error. All right, so now we have all of that. Now we want to delete all of these individual educational attainment. The problem is if you were to delete these, it'll change the formula that is calculating the total EDU. So what we need to do is copy this guy. So now we've copied this entire one, and then with it still there, we're going to go to Home, and then Paste, and then do the drop down right here, and tell it to paste just the values, right? And now, if we take a look at one individual, it's no longer a formula that's creating it. So now we can get rid of all the educational attainment. Boom. All right. So now we've got something that we can sink our teeth into. Pretty basic, right? So we've got GIS join. We need that one. We definitely want state, county. We've got total pop, total EDU, and total income. Now we can get rid of row 1 because row 2 because row 2 is extra information. And I think I blew it. I think I should have total pop up here in row 1. So let's do that. Let's just copy this guy, Control C, and put it up here. I want one clean header is basically what I'm after, right? Well, what did I say to do? Let me just make sure. I did say to delete the second row, so that's what I'm going to do. So I put these in the wrong row, but that's okay. We can do this. We have the technology, right? And then we want total income to go into row 1 too. Either way, you got to end up with one clean header row, otherwise GIS won't work well with it. So now I'm going to get rid of this guy. Okay, cool. So now we've got just one clean header row, and we've got the data that we want. We'll save it, and I'll just keep it in its name and as a CSV. Technically, ArcPro should read the new workbook format, the XLXS, but I know for a fact that it'll read the CSV, so we'll just leave it there. Okay, and then we can close. Definitely close your Excel file. Don't try to join files in ArcPro if Excel is still open. All right, and let me go ahead back to Pro, get a drink of water. And as you saw there in the video, the Excel should look like this. And just real quick, in the instructions, I give you what it should look like there. Okay? All right. Move this guy back. So this is a bit of a longer lab, and it takes time. So I'm going to just go through the first part of the lab today in this video, and then I'll make a second video that shows the analysis using the geographically weighted regression. Okay, so this is just setting us up to make some basic Choropleth maps of percent educated, average income, so on and so forth. All right, set up the map workspace. So we're going to go up here and go into this new map, and we're going to insert a new map. And so this is just going to create a new map pane, which is good. And then from this pane, it automatically gives us a background map. That's fine. We're going to go to Add Data, and we're going to go to our database for this particular lab, into our data set, and add the U.S. counties from 2010, and see how it automatically projected it. So we're in this Albers contiguous U.S. conic, okay? So it's an equal area projection, which is perfect for doing Choropleth mapping. You got to have an equal area projection if you're doing Choropleth mapping. Okay, let's save the project just to be sure. Save early, save often. Avoid nightmares of losing an entire project that you haven't saved. So now we're going to do a join, right? So if we look at the attribute table for the counties, it doesn't have any data on income or education in it, right? It has that GIS join field though, and that's what we're going to use. So if I right click on this layer and go down to joins and relates, and then go add join, it's going to bring up a tool. So there we go. And now I'm going to navigate to my table, through here, and we should be able to get into the raw data folder, and then that CSV file. You don't want to add the code book, because remember, that's just the metadata. Say OK, and then the input join field is going to be GIS join, and it should find the matching field there, and keep all target layers. You could hit validate join. It might find an error, and I'm guessing that this is probably GIS join field is unindexed, right? So it's just a warning. So the little exclamation point with the yellow triangle, it's just letting you know that there might be an issue, but there's not going to be an issue, because I've run this before and it's no problem. It's the red exclamation points or X's that says something is wrong and it's not going to work that you really have to worry about. So let's go ahead and add that join. And it did its thing. And now you can scroll over to the end and boom, you can already see them in there. So we've got our total income, our total EDU, and our total POP that are matched to our counties in the United States. So for this particular study though, we're just going to look at the contiguous United States. We're going to unfortunately have to get rid of old Alaska, Puerto Rico, and Hawaii, okay? It's not the end of the world, it happens all the time. They're not so keen on it when we do it, but it just makes it easy for us to do our geographically weighted regression later in the lab, all right? So to make this join permanent now we need to actually export that data out. So first things we're going to do is select by attributes. So let's see here, if we go to data up here for our feature layer, and then oh, nope, I'm sorry. I need to be down in the attribute table, which I already have open, and then I can do select by attributes. Cool. And we're going to say new selection, and we're going to have to do an expression, and it's not going to be by object ID. It's going to be by state. So if we go down to state, and instead of equal to, it's going to includes the values, and now when we do this drop down, we have a long list, and we can check Alaska. We can check Hawaii, and then we got to scroll down and get Puerto Rico. There's Puerto Rico, great. And so we're going to choose those three out, and we're going to say apply. Great, and we're done with this one. And so now we've got this 112 counties selected, and if you look up, you can see that all of Alaska should be selected. And now what we want to do is invert that selection. So you see this little switch button right here in the attribute table. We just hit switch, and that should have us set up to have only the continental United States. All right, so Puerto Rico, Alaska, and Hawaii are no longer selected, and now we can right-click on our data, go down to data and export features, not the table, we're actually exporting the features, so we're creating a new feature class, export features, and we're going to have to navigate and put it in the place we want. So it's already putting it in this lab's geodatabase, but we need to go one further and go into the geodatabase and into the featured data set. Okay? So it's going into the US data, and then we need to name it. And I called this thing Con US Join. So it's for the continental United States, join data. Okay? And let's see here. Super, and we'll say okay. And it should add it to our map project right away. Boom, it did. And so now I'm going to clear the selection. I'm going to turn off my US counties, and there I go. So I should have just the continental United States. I've got my total POP, total EDU, all of that. And actually, this is the wrong attribute table. Let me go ahead and open the con join attribute table. And there we go. And I'm going to scroll over. Yep, so it brought it all in, right? So I've got my total income, my total POP, so on and so forth. So I don't need my original shapefile with all the counties for Alaska and Hawaii and Puerto Rico as well. So I'm going to remove that one. Okay, and I'm going to save my project, and I'm going to check my instructions to make sure I'm leading you down the proper path. Okay, cool. There's a lot of stuff that's down here in this attribute table, and a nice thing kind of about the pro way of doing things is that you can hide things that you don't want to see. So I'm going to go from my GIS join back all the way to my shape here, Just hold down Shift and select them all, and then right click and say hide fields. Now they're not removed or anything, they're just hidden, so they're not in my face the whole time. So now I got a much more manageable attribute table. Shows my state, my county, and then the data that I'm interested in. All right, so I'm going to close this attribute table. I'm going to zoom to layer on my new counties, and I'm going to just real quick change this the symbology up. So what does the appearance look like? If I click symbology, that should open up my symbology tab. And right now I've got a single symbol. What if I wanted to do graduated colors? And I think in the lab I say to do this, symbolize it by total edu. So it's total pop right now, but what if I did total edu? All right, and it's breaking it up by natural breaks. It has 5 classes. Is this a valid choropleth map? Ask yourself, is it a valid choropleth map? I could even change the classification to something that might give me a more diverse map, but it's still raw data. And raw data is a no-no when it comes to a choropleth map, right? It's because of that mappable area unit problem that we discussed earlier in the lab instructions. Turns out you have to normalize this, so we're going to get into that in a second. Okay, so I'm going to switch back to my catalog view. And then down here under porthole, I'm going to click on Living Atlas, and I just want to add a layer of universities. So what if I search Living Atlas for U.S. universities? See what we get. All right, right there on top, colleges and universities. Okay, it's a feature layer, meaning it's going to come in as a shape file. It was created back in September. It's a federal user community, so it should be fairly robust. I'll right click on it and just say add to my map. And now if I go over to my map, we should have some universities. It's got crazy symbolization, but we can take care of that, okay? So instead of these unique values, let's go ahead and switch this up to a single value. Cool. And then let's see here. Oh, actually, I'm going to go to unique values, but this time, instead of object ID, I'm going to go down to the description of the North American industry classification. Okay? And it added all of them. I'm going to go ahead and remove all just so I can get to just one specific one, because I've already looked through this, and it turns out that the one that I'm interested in is, and if I open this up a little bit, colleges, universities, and professional schools. So that's the one I want to add, so I'm going to select that and hit OK. Okay, so now I have just one thing on there. And if it had the more show other values, see show other values is everything else, you can, under this more drop down, you can get rid of all other values. And now I can mess with the symbolization of this guy. So I'll just click on this. I'm going to go with a regular circle, go over to properties, tell it that I want it to be red, maybe. No outline, and 10 is a little big. Let's take this down to like 2. And this is just to give us an idea of where in the country we have universities. So interesting enough, we're looking at total education. This is raw numbers, so not a proper choropleth map, but there is an interesting relationship that you can see. The darker, more educated populace tends to be around where we have the location of universities. Surprise, surprise. So folks get a college degree and then they stick around and drive that economy. So that's what we're really after this time. We want to ask, does education attainment drive the median income of each one of these counties in the United States? And there's a number of schools of thought on this, and I go over it a little bit in the lab instructions, but one says that it's the percent of educated that drive the median income. And then some new economists came along and said, no, it doesn't matter what the percentage of educated people is, it matters the density. Because you can have educated people that never interact and they're not going to drive the average wages up. You need people that are educated to come together and be entrepreneurs and change the median income of a county. Well, we can test that. But first we're just going to make some simple choropleth maps looking at the differences in these particular numbers, okay? All right. So we'll need to make a couple of fields now in the attribute table so that we can calculate some things like the total percent of educated, the education density, and so forth, right? So let's see here. Let's open up the attribute table. So there we go. And ArcPro is a little bit different as far as creating fields and stuff. You have your attribute table and you have the add field down here. So I'll go ahead and add a field. And the first one that I need to take care of is going to be the total area, because I'll need that to calculate densities. So total underscore area. Oops, there we go. And hit enter. I'll make it a double as far as its type, and that just means it can go out to 6 decimal places. I might not need them all. And then I'll go to my numeric, and I'm just going to say that this thing is going to be a numeric operator with 2 decimal places. So the data is still in there. If I wanted to change that and take it to 4, I wouldn't need to recalculate. So say OK. And then the thing with the attribute table and adding fields is you need to go up here and save it after you've done it. So I'll save it. Cool. And then I'll go back to my original one, and now I have a new field for the total area. And I can right click on it and go to calculate geometry, and this tool will pop up. So the target field is this total area. The property that we want to calculate is area. The aerial unit, since we're scientists, let's work in metric, square kilometers. And then the coordinate system, we're just going to go with what the current map is, because we know that it's that U.S. contiguous United States Albers equal area. All right, and then I'll go ahead and calculate it. And let it run. And it shouldn't take too long. It went faster last time, but let's see. Gives me a second to get a drink of water. That's running slower than I would expect. Oh, there it is. Boom. Okay, so each county in the United States set up with a total area. So we're going to need that in order to calculate our densities. But we're going to need to first calculate a couple of things like percent educated and average income. So we have a total income, and we have a total population and a total educated, which is all we need in order to calculate out some of these other ones. So I'm going to go back over to my fields, and I'm going to add a couple of new fields. So real quick, let's add a field down here. Click here to add a new field. This one's going to be percent edu. Great. Oh, you have to hit enter to get it to stick. Yep, and then under, I'll just keep with my doubles, and then I'll go over to numeric. And I'm not going to set it as a percentage because I want to keep it as a decimal for now. But I am going to go ahead and just make it 2 decimal places. Let's make it 3. But that way we have plenty of data in there. Okay. Great. And save that one. Super. And then I'll scroll down and make one more. And this one is going to be called average income. So average income. Cool. And you notice I'm not letting any spaces creep in. We'll also make this one a double. Oh, you have to hit enter. How many times do I have to make the same mistake? And this one is going to be also numeric. But since it's going to be money, 2 decimal places is plenty, right? We only have the need for the dollars and cents, and then we'll save that guy. Cool. And now if I go back to the actual attribute table, I should have 2 brand new attribute tables. All right, so the percent educated, right click, and this time instead of the geometry, we're going to calculate the field. So the field calculator will show up. And it's fine if it's used in Python. This is a really simple calculation. So really what it's saying is percent edu equals, the equal sign is right there, and we don't even need to get into the complex code block. We can simply tell it that percent educated is the total educated, right, divided by the total pop. And that's going to give us our percent educated. And then we'll go ahead and say OK. And let that run. And there we go. So it's in percentage, but it's displayed as a decimal, which is fine. And now we're going to do our average income. Calculate the field. And I give you guys these formulas in the instructions. It's really not that hard. Again, same thing. We don't need a complicated code block. We have just the average income equals total income. So we'll scroll down. Total income divided by the total pop. And this is going to tell us the average income of a person in each county, right? And we'll say okay. Tell me that there was a small warning. What was it? One row was set to null. Okay, what was the problem? So I'm just going to double click on average income to get a, all right, so it appears that Pennsylvania Clearfield, didn't have a total income for some reason. Well, I could go back and look in my attribute table and figure that out, or I could look it up on the internet and figure it out. Either way, you'd be able to fill this in for total income and then go ahead and recalculate the average income. All right, not the end of the world. It's good to look into your errors though and see what's going on. So I'll resort it by object ID. So there we go, we're back to normal. All right, so now if I'm going to go ahead and turn off these fields, go back to my map, now I can make a map that is properly normalized. So what if I were to do by %edu right now? So there we go. So now this is a Choropleth map that we can sink our teeth into, right? So we've got %educated. It's not normalized because we already calculated the normalization. We're doing a method of geometric interval, and I'll talk more about which classes we should choose for these different Choropleth maps. And actually it has more to do with the histogram, right? So looking at this, it looks like it's slightly skewed, and a geometric interval sometimes is the best way to go. Another one that's usually the default is the Jenks natural breaks. There it is up there, natural breaks, and that will usually give us a fairly clean Choropleth map as well. The thing is we're going to be comparing these maps to each other, so it's important for us to use the same classification system for maps that we want to have directly comparable. Okay, and I'm going to even just turn off the colleges to give me a look at it. All right, not looking too bad. So that's our average income, and then we can make maps of each one of these. So what I would probably do is I would go ahead and add a new map under Insert, right? So add a new map, and then in that layout, go ahead and create your Choropleth map for %educated, and then add another map, and you could even name it up here, right? So if I were to add a new map, great. So we have a new map, and I can right-click on this guy, and, or is it over here? I think it's over here. Yep, there you go. I double-clicked on it, and so I can do %edu over here, right? And then I can make a %edu map, and I can go back to the map and add data. I can also copy and paste. So I could go to my original one and copy this US join, and then go over to my %edu and just paste it in there. There we go. Right? And it pasted exactly like it was over on the other one. So that's my %edu, and then I would go to a layout, add that map to it, add a legend, so on and so forth. Okay, I'm going to go back to my original kind of working map, and actually I'm just going to call this that. This will just be my working map. Right? And I've got to calculate a couple of other statistics. So I'm going to open the attribute table, and now I need to do my education density and my income density. So I need to add a field. Scroll down to the bottom. Here's one right here. So edu density. And this is going to end up being educated people per square kilometer, right? Stick with a double. And this is going to be numeric as well. And I'll just set it for a couple of decimal places. Great. And then save. Cool. And I need to add one more for income density. Now some people have asked, you know, is this income density, does this have any meaning? And I would say it's an interesting statistic. It's going to be dollars per square kilometer, right? So it's a way of figuring out really if the size of the county has anything to do with the kind of money that it's making. It gets really skewed though because Manhattan has an enormous amount of capital in a very small area with Wall Street, right? So that's one that kind of throws it off, but it's still an interesting thing to look at. All right, change this guy to a double, and it's numeric, but we know it's going to be dollars per square kilometer, so we'll just keep it at 2 decimal places. Very good, and then save that as well. And then we can calculate these two. All right, and And if I scroll over here, so EDU density, right click and say calculate field. And the education density is just going to be simply total EDU divided by the total area that we calculated before. So divide by total area. And we'll say OK. And there you go. So that's the number of people educated per square kilometer, right? Because our total area was in kilometers. So in some places like this Fairfax, Virginia, 1,000 educated people per square kilometer. That might have an effect on the average income of that particular county, right? All right, and then the income density. So let's take a look at that. Calculate field, and that's just total income divided by total area. So total income divided by total area. Oh, where did I get that one at? There it is, total area. Remember, shape area is something that's automatically calculated by GIS, and it's not in units that are valuable for this. So we have to use the area that we calculated, right? It still has that same warning, right? Because we still have that one county that we didn't fix in Pennsylvania. That'd be important to go and fix. All right, so income density. Now you're talking some big dollars. Let's see what the highest one is. So that's the lowest one. That's that Pennsylvania county. Let's double click again. Ooh, look at this. So we're talking billions of dollars, or is it even more? Yeah, this is $1.5 billion per square kilometer. So that kind of throws the income density thing off for that little tiny area in New York, right, around Wall Street. And it was very interesting. Okay, so this is a good place to stop for part 1 of this Applications of GIS Lab 1. You're going to make 4 Choropleth maps. I want you to make a map of the percent educated, of the average income in each county, the education density, and the income density. Try to use the same method of classification, the same number of breaks, and that way your maps will be semi-directly comparable. For part 2, we're going to really use some of the statistical tools in geographically weighted regression that will allow us to understand the relationship between education density and education percentage versus the median income. All right, if you like this video and it helps you out, please give it a like, go ahead and subscribe to the channel, and remember the instructions for the lab are right below in the description. Thanks a lot and have a good day.